Welcome to the SkyRadar video channel. This webinar introduces the SkyRadar PSR-Pulse simulator, the SkyRadar CW, and FMCW simulators, synthetic aperture radars SAR, inverse synthetic aperture radars iSAR, and a broad variety of secondary surveillance radars, including Mode S, Mode A, and Mode C. Best consult the SkyRadar website to see that most recent lists of available simulators. The presentation is given by Dr. Ulrich Schulten from SkyRadar.
Hi folks, my name is Uli Scholten. In this video I will present SkyRadar's PSR and SSR simulator. It's the first simulator for ATC-oriented personnel, controllers and technical experts, where more than 100 concurrent controller work positions can be operated in the same time. We allow for at least 8 pseudopilot positions, meaning those positions as you see them here, where you set up the airspace. I did set up 3 aircrafts. One with a speed of 245 meters per second, with an angular course of 90 degrees, and with a position in the airspace of 50 kilometers to the x-axis, 50 kilometers to the y-axis, and an altitude of 1000 meters. I can switch on the terrain, I can change the polarization, I can change power, max range, resolution and azimuth step. Here we see that airspace in the Pulse radar. You see the PPI, you see the 3 aircraft, you see the terrain, you see the B-scope view with 3 aircrafts, and you see the A-scope. You saw the aircraft here? We can set sensitive time control, amplification, threshold limiter. But we will talk about this later. Other simulators are CW, which measures speed, or here the FMCW, which you see in the A-scope now, in the B-scope and in the PPI, which gives a different representation of our objects here and here, as you saw it in the CW. Let us have another glance when it passes this object. You see it in the 3 different representations, and you'll see the A-scope reacting. iSAR and SAR offer different variations of measuring cross-sections of aircrafts. You see here how the A-scope comes up, now the B-scope. And the PPI doesn't give such a good view as the B-scope for a cross-section. We got a second rotation. Soon we should see it in the B-scope again, in the A-scope and in the B-scope. The aircraft comes up now here. Beautiful cross-section. Let's now look at the secondary surveillance radar. We have the PPI scope, and in the PPI scope we get signals of aircrafts It's a collaborative scenario. We only get the signals when we get signals actively sent from the transponders of the aircraft. You will see here now the first case, two overlapping aircrafts. We always display the data of the second tracked aircraft. You see that overlapping, so we see two aircrafts very close. You'll see later on, once we switch the alert mode on, that the controllers get an automatic system alert in such cases. But let's look at the system itself. We have here the second aircraft. When we look at the signals, we get the input from Mode A, we get the Mode A identification of the last aircraft, we get the input of Mode C, you see here and here the side lobe suppression, we get the height from Mode C, we get the input from Mode S, and we get here the identification data. You always see the binary pulses, which we are getting in and which we're displaying here. When we go a little bit down, we see what these binary pulses actually mean. It's the ICAO aircraft identifier, it's the velocity, it's the course, it's the height, and it's the collision avoidance distance which we measure from a reference aircraft. Let's have a look at collision avoidance. I switched it on, so the system will now do one circle and will check whether there's any aircraft that is too close to a second one. You see, it has tracked here already an alarm situation, and we have here with the second aircraft, we've got the warning that this one is flying below the prescribed height, which is set here as a simple reference figure, 500 meters. You can switch it off again, and we can set a map. This map here is a live map which we get through Google Maps, and we'll now again track the aircrafts, and they will be positioned in the context of the geographical situation. On mouse over, we actually get the information on the aircraft. ICAO number test 02, velocity 400 meters, course 90 degrees. There's lots of data that is communicated in the packages of a secondary surveillance data. We show here the data that is actually communicated in the package. It's just a fraction of it, and it will allow for further analysis.
Thank you, Uli. Read more about the latest news on radar training equipment, radar research of free learning media on www.skyradar.com.